So in this video, we'll discuss the problems on electrochemistry based on Nernst equation. So how do we write the Nernst equation for any electrochemical cell? So we write it as E cell equal to E naught cell minus 0.059 volt divided by N log of anode ion raised to the power X divided by cathode ion raised to the power Y at 25 degrees Celsius. So this is the equation used at 25 degrees Celsius or 298 Kelvin. Either we can say at 25 degrees Celsius or at 298 Kelvin. So what is this E naught cell? It is a standard electrode potential obtained by calculating E naught of cathode minus E naught of anode. E cell is the electrode potential at any concentration. At any other concentration than 1 molar, we can calculate the EMF of a cell using Nernst equation. Then N is the number of electrons lost or gained. X is the number of moles of anode ion in a balanced chemical equation. So this X is number of moles of anode ion in balanced chemical equation, and Y is the number of moles of cathode ion in balanced chemical equation. So we'll go with the next question given. So it is a question given here. Write Nernst equation for Daniell cell. So you should know that in Daniell cell, zinc is anode and copper is cathode. At anode, always oxidation reaction occur. So the overall reaction we can represent it as zinc in solid state plus of copper ion in aqueous state results in the formation of zinc ion in aqueous state plus of copper in solid state. Now when we compare it with that of the Nernst equation given above, so it was a Nernst equation given here, E cell equal to E naught cell minus 0.059 volt divided by N log of anode ion to the power X minus cathode ion to the power Y. So generally how we can write the Nernst equation, since we don't know its E naught cell value, general equation we can write it as E cell equal to E naught cell minus 0.059 volt divided by N. N value we can find out by looking at the reaction. So zinc loses 2 electron, copper ion gains 2 electrons. So N value is equal to 2 into log of. So this is your anodic reaction. So this is your anodic reaction, means Zn2 plus is your anode ion. You have only 1 mole, so directly you can write it as concentration of Zn2 plus divided by copper undergoes reduction. That means it is a copper reaction, cathode reaction, and at cathode you have copper ion, so divided by Cu2 plus. So this becomes your Nernst equation for Daniell cell. So similarly, we'll see for the next one how we can write the Nernst equation. ಹೇಗೆ ಬರಿಬಹುದು Nernst equation? We'll try to understand. ಇಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? 2 moles of aluminium, then 3 moles of nickel ion, then 3 nickel and 2 Al plus. ಈ ರಿಯಾಕ್ಷನ್ ಬೇಸಿಸ್ ಮೇಲೆ Nernst equation ಅನ್ನು ಬರಿಬೇಕು. What they expect here when you are writing Nernst equation, E cell ಮತ್ತೆ E naught cell value ಕೊಟ್ಟಿಲ್ಲ. So don't worry about it. E and E naught cell you write it as it is. N value ನೀವೇ find out ಮಾಡಬೇಕು based on the balanced chemical equation, that is number of electrons lost equal to number of electrons gained. And anode ion easily you can find out by the reaction, ಮತ್ತೆ cathode ion ಕೂಡ reaction ನೋಡಿ find out ಮಾಡಬಹುದು. So ಇಲ್ಲಿ ನೋಡಿದಾಗ ಅಲ್ಯೂಮಿನಿಯಂ Al ಇಂದ Al3 plus ಗೆ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ಅಲ್ಯೂಮಿನಿಯಂ is undergoing oxidation. So if it is undergoing oxidation, ಅದನ್ನು ಯಾವ ರಿಯಾಕ್ಷನ್ ಅಂತ ಹೇಳ್ಬೋದು? Anode reaction. And ion here is Al3 plus. So your anode ion is nothing but Al3 plus. Similarly, if you look up, ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ? Ni2 plus is forming Ni. That means from plus 2 it is changing to 0 oxidation state. It is undergoing reduction. And when it is undergoing reduction, it is which reaction? Cathode reaction. So ನಿಮ್ಮ cathode ion ಏನಾಗ್ತದೆ ಇಲ್ಲಿ? Cathode ion is equal to Ni2 plus. So now we'll write the similar equation here, that is Nernst equation. Nernst equation ಬರೆಯುವಾಗ how we can write it as E cell equal to E naught cell minus, that is we are writing E reaction ಯಾವ temperature ಅಲ್ಲಿ ಬರೀತಾ ಇದ್ದೀವಿ? At 25 degree Celsius. So we can write it as E cell equal to E naught cell minus 0.059 volt divided by N value easy find out ಮಾಡಬಹುದು. If you look here, plus 2 oxidation state. ಒಂದು ನಿಕ್ಕಲ್ ಅಯಾನ್ +2 ಇಂದ 0 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟಿಗೆ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ಇಟ್ ಈಸ್ taking 2 electron. One is taking 2. So 3 2s are, they are taking totally how many electrons? 6. So 6 electrons are gained by nickel, 3 moles of nickel. In the similar manner, if you look at aluminium, so from 0 to +3, andre 1 aluminium 3 electrons anna loss ಆಗ್ತಾ ಇದೆ. It is losing 3 electron. 2 aluminium ions are there. So 2 3s are 6. So number of electrons lost and gained are equal to what here? 6. So your n value ಏನಾಗ್ತದೆ ಇಲ್ಲಿ 6. So we'll write here directly as 6 into log of anode ion to the power x. So ಇಲ್ಲಿ ನಮ್ಮ anode ion ಏನಿದೆ? Anode ion Al3+ ಇದೆ. So Al3+ raised to the power ಎಷ್ಟು number of moles ಇದೆ? 2. So raised to the power 2 divided by cathode ion ಏನಿದೆ ನಮ್ಮದು? Ni2+. How many moles of Ni2+ are there? 3 moles are there. So Y value becomes 3 and this becomes your Nernst equation for the given electrochemical cell at what temperature? Idanna ನೆನಪಿಟ್ಕೋಬೇಕು 25 degrees Celsius or 298 Kelvin. So here this is the Nernst equation. Now we'll solve the problems on this. So whenever you solve the problems on Nernst equation, always be careful, be patient to read the question. ಮೊದಲು ಕ್ವೆಶನ್ ಅನ್ನು ಕರೆಕ್ಟ್ ಆಗಿ ಓದ್ಕೋಬೇಕು and then you have to solve the problem. So what's the question given? We'll read it. Use the Nernst equation for the following cell at 298 Kelvin and calculate EMF. So ಇಲ್ಲಿ ಏನು ಹೇಳಿದ್ದಾರೆ? ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ 298 Kelvin. They have asked you to calculate the EMF of a cell. So ಇಲ್ಲಿ cell representation ಕೊಟ್ಟಿದ್ದಾರೆ. Cell representation ಕೊಟ್ಟಿದಾಗ always on left side it is anode and on right side it is cathode. Double line indicate that salt bridge. So ಇಲ್ಲಿ ನಿಮ್ಮ anode ion ಯಾವುದಾಯಿತು? Al3+. Cathode ion ಏನಾಯಿತು? Cu2+. So you can write a balanced equation so that you get the value of n. So balanced equation ಬರೆಯುವಾಗ what would be your equation? Anode ion means it should undergo oxidation, means aluminium changes to Al3+. And reactant ಇಲ್ಲಿ ಏನಾಗ್ತದೆ? cathode ಅಲ್ಲಿ copper ion changing to copper, that means it should undergo reduction. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಆ್ಯನೋಡ್ ಅಂದರೆ ಯಾವತ್ತು ಯಾವ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕು? ಆಕ್ಸಿಡೇಷನ್. ಮತ್ತು ಕ್ಯಾಥೋಡ್ ಅಂದರೆ ಯಾವ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕು? ರಿಡಕ್ಷನ್. ಆ್ಯನೋಡ್ ಆಕ್ಸಿಡೇಷನ್, ಕ್ಯಾಥೋಡ್ ರಿಡಕ್ಷನ್. Now we'll balance it. So here if you look, electrons are not balanced. Here you have 2, here you have 3. That means 2 electrons are gained, 3 are lost. So to balance it, we'll multiply this by 3 and this by 2. Now if you look here, 3 2s are 6 electrons are lost, 2 3s are 6 electrons are gained. Sorry, 6 electrons are gained here and 6 electrons are lost. So to balance overall, ಇಲ್ಲಿ 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದಕ್ಕೆ ಇಲ್ಲಿ ಕೂಡ 2, ಇಲ್ಲಿ 3 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದಕ್ಕೆ ಇಲ್ಲಿ ಕೂಡ 3. So this is our balanced chemical equation. We have written this balanced chemical equation just to get the n value, and we will get our n value as 6. As we see here, 3 2s are 6. From +2 to 0 means it has undergone reduction, gained 6 electron, and here 0 to +3 means one has lost 3 electron, totally 2 has lost 6 electron. Now we will write our Nernst equation and try to solve the problem here. So the Nernst equation here we can write it as E cell equal to E naught cell minus of 0.059 volt divided by n log of anode ion to the power x divided by cathode ion to the power y. Now we'll substitute the values. E naught cell first we'll find out. So when you read the question here, E naught cell is not completely given. So if you look here, they have given E naught of Al3+, E naught of Cu2+. And based on this notation, we know that Al is anode and Cu is cathode. That means this is nothing but your E naught of anode and this is nothing but E naught of cathode. So we'll calculate E naught cell. E naught cell is calculated as E naught of cathode minus E naught of anode. E naught of cathode value ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? plus of 0.34 volt minus E naught of anode ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ minus of 1.66 volt, which is equal to, so we'll try to calculate it. So when we calculate it, what we get here, 0.34 plus of, minus into minus was plus of 1.66. So when we calculate it, here it becomes equal to 2. So here the value is 2 volt. Now next we will go with the next term. E naught cell we have calculated, En already calculated 6. Anode ion we know it is Al3 plus. X value, how many moles of anode ion are there? 2 moles. Cathode ion it is Cu2 plus, how many moles are there? Y is equal to 3. Now concentration of anode ion they have given in the question. So here it is 0.01. That 0.001 I can write it as 10 to the power minus 2 molar. So this is nothing but concentration of Al3 plus ion, and concentration of Cu2 plus they have given it as 0.0001, which I can write it as 10 to the power minus 3 molar. So this we can take it as a concentration. Now we will go with the solution here. So E cell equal to, E naught cell hego calculate ಮಾಡಿದೀವಿ, how much we have got here? 2. So 2.0 volt minus 0.059 volt divided by 6 log of anode ion. Anode ion ಏನಿದೆ Al3 plus, ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 10 to the power minus 3. And here number of moles of anode ion in the balanced chemical equation is 2. So 10 to the power minus 2 raised to 2 divided by cathode ion. Cathode ion concentration ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? 10 to the power minus 3 raised to the power y. ಎಷ್ಟು moles balanced equation ಅಲ್ಲಿ ಇದೆ? 3. So 10 to the power minus 3 raised to 3. 1, 2, 3, 4. Sorry, it is 1, 2, 3. It is 10 to the power minus 3. This is 10 to the power minus 4. So 10 to the power minus 3 raised to 2. 10 to the power minus 4 raised to 3. Now we'll solve it. So when we solve it, what do we get? We'll check it. 2.0 volt minus of 0.059 volt divided by 6. So here 10 to the power minus 3 to, it is nothing but a to the power m the whole raised to n, which is a raised to m into n. So 3 2s are 6. So we get it as log of 10 to the power minus 6 divided by 10 to the power minus 4. 4 3s are 12. So 10 to the power minus 12. When 12 goes up, it becomes plus 12. So we can further simplify it as 2.0 volt minus 0.059 volt divided by 2 into log of 10 to the power minus 12 goes up, plus 12 plus 12 6 is plus 6. And you should know that log 10 to the power n is equal to n. So log 10 to the power 6 becomes equal to 6. Hence we can calculate it as 2 volt minus 0.059 volt divided by 6 into 6. So here 6 gets cancelled. So 2. So when you calculate here 2.0 minus 0.059, you get the answer as 1.941 volt. So here the correct answer is 1.941 volt. So this is how we calculate E cell. So E cell equal to 1.941 volt. So we'll go with the next question. So in the next question they have asked you to calculate the EMF of the cell in which the following reaction takes place. So the reaction given is Ni solid state plus 2 Ag plus 0.002 molar forming Ni2 plus 0.160 molar plus 2 Ag. They have given the concentration. Based on the equation you can identify which is your anode ion and which is your cathode ion, as well as you can identify Vn value. So here if you see Ni from 0 oxidation state changes to plus 2, means it is undergoing which reaction? Oxidation, as the oxidation number increases, and oxidation always occurs at anode. So your anode ion is equal to Ni2 plus, and its concentration is 0.160 molar, which I can write it as, if after shifting the point 1 2 digits, so 16 into 10 to the power minus 2 molar. Similarly, if you look here, you are having Ag plus and Ag. Now here Ag plus to Ag means plus 1 to 0 oxidation state. It is reduction reaction as the oxidation number decreases, and hence our cathode ion here is, so cathode ion is Ag plus, there are 2 moles of cathode ion, so Ag plus to the power 2, and its concentration is given as 0.002. So if I shift the point 1 2 3 digits, it becomes 2 into 10 to the power minus 3 molar, and this also raised to the power 2. So we'll write the Nernst equation for this cell. So when you write the Nernst equation, it becomes E cell equal to E naught cell minus 0.059 volt divided by N into log of anode ion to the power X divided by cathode ion to the power Y. Now I will substitute it. So E cell equal to, E naught cell is already given, it is equal to 1.05 volt minus of 0.059 volt divided by N. N value is, so here if you see nickel changes from 0 to plus 2 means 2 electrons are lost, plus 1 2 moles are there, so 2 into plus 1 is plus 2, plus 1 to 0, that is plus 1 to 0 means it's gaining 1 electron, 1 ion gains 1 electron, 2 will gain totally 2 electrons, so N value here is equal to 2, so 2 ಮತ್ತೆ ಇಲ್ಲಿ log of anode ion ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, anode ion is Ni2 plus ion, and its concentration what we have found out here is, simplified it as 16 into 10 to the power minus 2. ಎಷ್ಟು moles of anode ion ಇದೆ, nickel ಒಂದೇ mole ಇದ್ದಕ್ಕೆ will keep it as it is. Next cathode ion, how many moles are there, 2 moles, and its concentration is 2 into 10 to the power minus 3 the whole raised to 2. ಈ ಲಾಗ್ ಅನ್ನು ಸೈಡಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಆಮೇಲೆ ಅದರದ್ದು ವ್ಯಾಲ್ಯೂ we will substitute it. So when you simplify it, what is given, log of 16 into 10 to the power minus 2 divided by 2 into 10 to the power minus 3 the whole square. Now here 2 square, 2 2s are 4. So 16 into 10 to the power, log of 16 into 10 to the power minus 2 divided by 4 into 10 to the power minus 6. 4 1s are 4, 4s are minus 6 goes up becomes plus 6, which is equal to nothing but plus 4. So what is left out here, log 4 into 10 to the power 4. Now when you take the log of it, log 4 value log table alli find out ಮಾಡಿದಾಗ you get it as 0.621, and log m into n is log m plus log n, and log 10 to the power 4 is 4. So here your value will be equal to 4.6021. We'll substitute it here. Now when we substitute it here, what do we get? We'll see E cell equal to 1.05 volt minus 0.059 volt divided by 2 into 4.6021. So when you simplify it and calculate the answer, simplify ಮಾಡಿ calculate ಮಾಡಿದಾಗ how much we get, we'll check it. So here first we will simplify this term and then deduct with it. So when you simplify this term, what is the term here, 0.059 into 4.6021 overall divided by 2. So you get it as 0.13576. Then here it is given minus 1.05. So here 0.914 is the correct answer. So 0.914 volt is the correct answer. So you get the E cell value as 0.914. So this is how you have to solve the problems on EMF of a cell. We'll go with one more problem. So here the question given is, calculate the EMF of a cell if E naught of Mg2 plus bar Mg equal to minus 2.37 volt and E naught of Ag plus bar Ag equal to 0.80 volt. This is the equation given. So based on the equation you come to know that Mg changes from 0 to plus 2 oxidation state. It is an oxidation reaction. Oxidation occurs at anode, hence your anode ion is Mg2+. ಮತ್ತು ಆ್ಯನೋಡ್ ಅಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 0.001. ಅದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಬರೀಬಹುದು 1 2 3. ಇಫ್ ಯು ಶಿಫ್ಟ್ ದ ಪಾಯಿಂಟ್ ಬೈ 3 ಡಿಜಿಟ್ಸ್ ಏನಾಗ್ತದೆ 10⁻³ ಮೋಲಾರ್. ಅದೇ ರೀತಿಯಲ್ಲಿ Ag+ ಅಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇಫ್ ಯು ಗೋ ವಿತ್ Ag+ ಟು Ag, ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ Ag+ ಅಲ್ಲಿ your concentration of Ag+ is ಫ್ರಮ್ +1 to 0 ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ಇಟ್ ಈಸ್ ರಿಡಕ್ಷನ್ ಯಾವತ್ತು ಎಲ್ಲಿ ಆಗ್ತದೆ ಕ್ಯಾಥೋಡ್, ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ನಿಮ್ಮ ಕ್ಯಾಥೋಡ್ ಅಯಾನ್ ಏನಾಯಿತು Ag+. ಎಷ್ಟು Ag+ ಇದೆ 2. ಸೊ Ag+2, ಆ್ಯಂಡ್ ಇಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ 0.0001 ಮೋಲಾರ್. ಸೊ ನೀವು ಪಾಯಿಂಟನ್ನು ಶಿಫ್ಟ್ ಮಾಡಿದಾಗ 1 2 3 4 ಡಿಜಿಟ್ಸ್ ಏನಾಗ್ತದೆ ಇಲ್ಲಿ 10⁻⁴ ಮೋಲಾರ್, ಆ್ಯಂಡ್ ಓವರ್ ಆಲ್ ರೇಸ್ ಟು 2 ಬಿಕಾಸ್ ಇಲ್ಲಿ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 2 moles. ಎನ್ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು ಈಸಿಯಾಗಿ. ಸೊ ವಾಟ್ ವುಡ್ ಬಿ ಯೋರ್ ಎನ್ ವ್ಯಾಲ್ಯೂ ಹಿಯರ್? Mg 0 ಇಂದ +2ಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ ಮೀನ್ಸ್ ಇಟ್ಸ್ ಲೂಸಿಂಗ್ 2 electron, ಆ್ಯಂಡ್ Ag +1 ಇಂದ 0 ಅಂದರೆ ಗೇನಿಂಗ್ 1 electron. ಒಂದು ಅಯಾನ್ 1 electron ಗೇನ್ ಮಾಡ್ತದೆ. ಬಟ್ ವಿ ಹ್ಯಾವ್ ಹೌ ಮೆನಿ ಅಯಾನ್ಸ್ 2 ಅಯಾನ್ಸ್ ಅಂದರೆ ಇಟ್ ವಿಲ್ ಗೇನ್ 2 electrons. ಸೊ ನಂಬರ್ ಆಫ್ electrons lost it should be equal to number of electrons gained, and they are equal to what here 2. N value we have found out. Now next one more what we require is E0 cell. So E0 cell ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾರೆ already we have seen. We calculate it as E0 of cathode minus E0 of anode. So E0 cell equal to E0 of cathode ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ here magnesium is our anode, silver is cathode. Silver value ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 0.80 volt minus magnesium minus of 2.37 volt. ಸೊ ಅದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ how much we get, we'll check it. .80 plus of 2.37 which is equal to 3.17 volt. So we get it as 3.17 volt. So we have got all the values. E0 value. Now we'll write the Nernst equation. Nernst equation ಯಾವ ರೀತಿಯಲ್ಲಿ ಬರೀಬಹುದು? E0 cell equal to E0 cell minus of 0.059 volt divided by N into log of concentration of anode ion to the power X divided by cathode ion to the power Y. So E cell equal to E0 cell already calculate ಮಾಡಿ ಆಗಿದೆ. ಎಷ್ಟು ಬಂದಿದೆ 3.17 volt minus of 0.059 volt divided by N value already calculate ಮಾಡಿದ್ದೀವಿ, it is equal to 2. So divided by 2 log of anode ion ಅಂದರೆ magnesium ion, we have got it as 10⁻³ molar. ಒಂದೇ ಮೋಲ್ ಇದ್ದಕ್ಕೆ we'll keep it as it is. Cathode ion already we have found out, it is equal to 10⁻⁴ and 2 moles are there. So we write it as 10⁻⁴ the whole raised to 2. Now when we simplify it, ಮಾಡಿದಾಗ what we get, we'll check the answer. E cell equal to 3.17 volt minus 0.059 volt divided by 2 log of 10⁻⁻3 minus 4 into 2 is 8, minus 8 ಮೇಲೆ ಹೋದಾಗ plus 8. So we'll simplify this. So when we simplify we get it as E cell equal to 3.17 volt minus 0.059 volt divided by 2 log of minus 3 plus 8 log 5 ಆಗ್ತದೆ. log 10⁻⁵ already as I have said you, log 10⁻n is equal to n. So what do we get here? E cell equal to 3.17 volt minus 0.059 volt divided by 2 into 5. So ಇದನ್ನು simplify ಮಾಡಿ what is the answer we get, we'll try to write it. So what is the answer we get, we'll check it. 0.059 into 5 divided by 2. So we get it as 0.1475. So 3.17 minus 0.1475 volt. So here E cell equal to, so 3.17 minus 0.1475 equal to 3.0225. So what is the answer we get? 3.0225 volt. So this is how we have to solve the problems on EMF, and these are almost important question usually repeatedly asked in your annual exam for 3 marks. Practice these questions. If any doubts you can ask. So thank you for watching. Prepare well for your exams.